What if the next big AI breakthrough doesn't happen on your screen? Inside a giant building that needs massive amounts of power, land, cooling, and water. From the outside, a data center can look completely harmless. A quiet industrial building near a highway. A warehouse on the edge of a growing city. No smoke, no crowds, no dramatic machines visible from the road. But inside, thousands of servers are running every second of every day. They power websites, cloud storage, streaming platforms, business software, and now artificial intelligence. Every chatbot response, every AI image, every AI video, every model being trained somewhere in the background depends on real physical infrastructure. AI feels invisible, but it is not weightless. It needs electricity, it needs cooling, and in many cases, it needs water. Some large data centers can use millions of gallons of water per day, depending on their size, location, climate, and cooling system. That does not mean every data center uses that much. Some use far less. Some use recycled water. Some newer designs are being built to use little or no water for cooling during normal operations. But as AI grows rapidly across America, one question is getting louder. How much water should America give to artificial intelligence? And who gets to decide? For most people, AI feels like magic. You open an app, you type a prompt. A few seconds later, words, images, code, or video appear on screen. It feels digital. It feels clean. It feels like the cloud. But the cloud was never really a cloud. It was always buildings, servers, power lines, cooling systems, water pipes, and people living near all of it. Artificial intelligence runs on powerful chips. Those chips sit inside servers. Those servers sit inside data centers. And when thousands of machines run together, they produce heat. A lot of heat. Too much heat can damage equipment, slow performance, and make the system unreliable. So data centers must be cooled constantly. Some cooling systems use outside air. Some use mechanical chillers. Some use closed-loop liquid cooling. And some use evaporative cooling, where water helps remove heat from the building. Evaporative cooling can be efficient for energy, but the trade-off is that some water is consumed in the process. And this is where the debate begins. Because the AI boom is not happening in an empty world. It is happening in real towns, real counties, real deserts, real suburbs, real farming regions, and real communities that already need water for homes, schools, hospitals, local businesses, and agriculture. Now, before we go further, it is important to be fair. Data centers are not the biggest water users in America. Agriculture uses far more water overall. Cities, factories, power plants, lawns, golf courses, and farms all compete for water too. So it would be misleading to say data centers alone are causing America's water problems. That is not the point of this video. The real issue is timing, location, transparency, and speed. AI infrastructure is expanding quickly, and many projects are being proposed in places where water, electricity, and land are already sensitive issues. A single data center may not look huge compared with an entire state, but for one town, one county, or one water district, the impact can feel much bigger. That is why residents and local officials are asking basic questions. How much water will this facility use? Where will that water come from? Will it use drinking water, groundwater, recycled water, or treated wastewater? What happens during a drought? Will electricity demand raise costs? Will the project bring long-term jobs? Will the public get clear answers before approval? One of the clearest examples is Texas. Texas wants growth. It wants investment. It wants technology jobs. And it is becoming a major market for data centers. But Texas is also a state where water is already a serious issue in many areas. Recently, Texas officials asked data center companies for more information about their water use. According to reporting from the Texas Tribune, less than 1/3 of companies responded to one state water use survey. That matters, because if officials do not know how much water data centers use today, it becomes much harder to plan for tomorrow. A city cannot prepare pipes, reservoirs, power systems, emergency plans, and utility upgrades based on guesswork. And ordinary residents may start to wonder whether large companies are getting fast approvals while local communities are left with the risk. This does not mean Texas should ban all data centers. The question is more practical. If a project uses public resources, should the public know the real numbers? Virginia shows another side of the story. Northern Virginia is one of the most important data center regions in the world. A huge amount of internet traffic passes through that area. Data centers there have brought investment, tax revenue, and jobs. But they have also created concerns about land use, electricity demand, water use, noise, and the speed of development. In 2026, Reuters reported that QTS, a company owned by Blackstone, terminated its planned digital gateway data center project in Virginia after years of local opposition and legal challenges. That does not mean data centers are leaving Virginia. Virginia is still extremely important to the industry, but it does show something important. Local resistance is no longer just background noise. It can shape major projects. And for many residents, the concern is not simply anti-technology. Most people use the internet. Many people use AI. Many people benefit from cloud services every day. But they still want a voice in what gets built near their homes. They want clear rules. They want honest numbers. And they want to know whether the benefits will actually reach the community. In Utah, the conversation is tied closely to water transparency. Utah has dealt with drought concerns and long-running fears about the future of the Great Salt Lake. As large server farms and AI-related infrastructure grow, lawmakers passed data center water transparency amendments, requiring certain developers to provide estimates of future water use. That is not a ban. It is not an anti-AI law. It is a transparency law. And that difference matters. Because many communities are not saying, stop technology. They are saying, tell us the cost before we approve it. How much water? How much electricity? How much land? How many permanent jobs? And who pays if local infrastructure is not enough? This is why the issue matters to average Americans. AI infrastructure does not only affect tech companies. It can affect water systems. It can affect electricity grids. It can affect land use. It can affect local politics. It can affect whether new power lines, substations, backup generators, and industrial buildings are built near neighborhoods. For some communities, data centers can bring major tax revenue. They can support construction jobs. They can attract investment. They can help America compete in artificial intelligence. But for other communities, the trade-off may feel different. A data center may use large amounts of power and water while creating relatively few long-term local jobs after construction ends. That does not automatically make it bad, but it does make the question more complicated. If a facility needs major public resources, people will naturally ask, what does the community receive in return? There is also an energy side to this story. AI does not only need water, it needs electricity. A major report from the International Energy Agency projects that global electricity consumption from data centers could roughly double by 2030. That growth is being driven by cloud computing, digital services, and especially artificial intelligence. Electricity demand matters because local grids must stay reliable. If a region suddenly adds several large data centers, utilities may need new power plants, substations, transmission lines, or grid upgrades. And if those costs are not planned carefully, residents may worry about higher bills, strained infrastructure, or reduced reliability. Again, this is not a simple story of good versus bad. It is a planning story. AI may be useful, but infrastructure has limits. And yes, AI can create real benefits. So this video is not saying AI should disappear. The better question is, can America build AI responsibly? The good news is that solutions already exist. Microsoft says one of its newer AI-optimized data center designs can consume 0 water for cooling during operations. These efforts matter, but they do not remove the need for local oversight. So what should communities ask for? Clear water reporting, honest power planning, smarter location choices, better cooling technology, and real community benefits, not just promises. For years, we talked about the internet as the cloud. But the cloud was never floating above us. It was always on the ground, in buildings, on land, connected to power lines, connected to water systems, connected to communities. AI is not just a technology question. It is an infrastructure question. Before America builds the next generation of artificial intelligence, maybe the country needs to answer a simpler question first. If big tech gets the profit, who carries the cost? Should AI data centers face stricter water and electricity rules before they expand? Or is this the price America has to pay to stay ahead in the global AI race? Let me know what you think in the comments. And if you want more clear, source-based explainers, subscribe to the Orbis.